Target 2 is flowing gradients. Please check your folder where we're going to get what we need. Check your folder. You will see a folder called classwork. That's the folder we're going to work with next. In the folder classwork, there is this RS folder. Open it. And you're going to see 2 gauges that are there with 1 Excel sheet. I've not opened this thing, but if I don't open, Lillian will talk about it. I'll check where it is and tell her to talk about it. The importance, now we're entering into real interpretation now. The other one just loading. Now we're entering into interpretation proper. When a wireline person goes to the field to acquire BHP data for you, that wireline man must come back with what we call field reports. Hello? Field reports. It tells you everything that happens in the field. In fact, if they stopped on the road, he will write it. When they got to the place, he will write it. Are you getting the time it happened? When they maybe a condition they were, he will write it. When they put their what's it called? The gauges into the lubricator, he will write it. And when they started running in hole, he would write everything. So you need that field report because sometimes they experience problem while trying to acquire this data. And when you load the data, you were not in the field. You don't know why what happened. Does it make sense? So it is that his report that will make you know that, oh, while they were trying to run in hole, they experienced a surge from the well. The surge is like an eruption from the well that comes if the well maybe have high GOR. Are you getting it? We call it eruptivity of the well. It just surges up. And once it's like that, all your data you get for that period will be distorted. So what they do is to wait. They might not do anything again. They might not run in whole again. So you now plotting, you will just see a distorted. That is what you see here, sequence of events. Can you open it? I just want to talk about it. Open your sequence of events in that folder. See, are you seeing what the guy came back with? He came back with this sequence of events. You will see it in every work, every field work from the gauge man, fire line man, slick line man, anybody. Once they go and come back, they'll give you this. So he tells you he got to this one self is not giving you all the story before. He went straight to the real thing. Before he started, he powered up his gauges. Abi, he made sure he put them in tandem. Tandem is that one is following the other one. Are you getting me? And then he opened the well to the lubricator. Are you getting it? He observed 5 minutes just to bleed off whatever pressure that has been trapped in the well. Are you getting? He'll give you all this, and this is what is going to help us do our static gradient and our flowing gradient. So now that you have known, what did I teach us when we want to load gauges? What did I teach us? What did I teach us? Good. So now open your gauge. I always like opening the lower gauge because you know when you tie something, they showed you how the gauges look like. Did they show you how they tie them? They showed you now. I saw it in your manual. How it's tied. You were not shown. This is gauge 1. This is the second gauge. They might be some foot apart from each other. Are you getting me? It's not always 4 feet. Oh. It can be 1 feet. It can be 1.5. It can be 2.5. Depending on what the gauge man wants to do. Are you getting me? So don't always believe that when you open your report, you will see 4 feet. In fact, for the past 6 years now, I've not seen anybody who did 4 feet. I've always seen 1 feet apart, 2 feet apart. Are you hearing me? In fact, for the past 10 years, I've not seen 4 feet. 4 feet now, you both people write that sapphire, this thing, you're seeing 4 feet. You get me? In Niger Delta here, no time, 1 feet apart, 2 feet apart, 2.5 feet. Okay? So let's move on. Yes. Now, the same thing you did, I've taught you how to load. I will not teach any. I won't even talk when I'm loading this one. So pick the date and pick the time. The only place I want to come in is during your PVT. When you get to PVT point, I have to come in. Is there any confusion so far? Pick the time, pick the date for your Entraco. The name of this one is Entraco 6 what? SS is the name of the field or the well. Entraco 6SS, upper and lower gauge. So pick that lower gauge. Check for me what's the time. Lily, write out the time for us. You've written it, okay. So I'm not talking to anybody. You just go straight. Load. You just finish one assignment. Now to load, I do file new. Are you seeing? I had something there before. The moment you say file new, it will bring up this blank page for you to enter your information. I'm going to leave every other thing default here because I'm not giving the information. But usually, this is a real data. You must ask for well schematic so that you can see your well bore radius. You can get it. You must ask for petrophysical information so that you can get your porosity, you can get your page thickness, you can get your perforated interval from your schematic. Are you getting it? Am I talking too much? No, but I'm sending the message across now. I'm saying in real work now, you have to, this information we're using default. In real work, you don't use default. The man will ask you, did I tell you my pay is 30? Somebody's pay is 80 something feet. You're going to write 30 for him. You remember when you people did calculation here, you did KH. What is KH? Eh? Full capacity for, so it's largely dependent on the age. The smaller the age, the smaller that KH. So you'll be cheating the company, telling them that this is what they have. Meanwhile, it's not what they have. So where it is 80 feet, don't go and write 30 and say, when. Now, I just want to make this look a little bit like a Niger Delta distance. I'm going to use 2-3. Is that okay? 2-3. I don't want to use 0.1. There is nothing new. See what I did. This is the old one you have saved. You can either close this in and start reopening again. I don't want to close and reopen. I just came here to tell you that I want to start a new project. I click on this blank document, or you go to File, New. Did it make sense? So I clicked on the blank document and it came out. I've not done anything. The only thing I did was to change this guy. I said I want it to look a little bit like a Niger Delta formation. It cannot be 0.1. Porosity, I change it to 0.3. Then come to this your, what is it called? Dates. Pick up your dates. I'm not talking again. So mine is 2017 May. Your months can never be 18. That's how you know. Do you understand? Are you okay? So if you're done with that, click on next. So this is where I wanted to show us. Now we don't have PVT reports, which is a requirement for you to do analysis. So we're going to use what we call, we're going to use correlation. Now to use correlation any day, anytime, this is what you do. You just come here and toggle this. Once you toggle it, this calculator will show. Let's say what you're looking for is only formation volume factor, which is B, and this guy and this guy. You click. Hello. Then you go to calculator. If you have this compressibility looks like the average total compressibility, formation compressibility we used to have. So you can just click here. Click on the calculator. There is a calculator there. Have you seen it? Once you toggle on formation volume factor, CT, and all those things, click on that calculator button that is there. So now it brings you here. I'm going to leave this default. This is why I told you that what you need, the minimum information when you don't have PVT information any day, anytime, is your in situ parameters from the field. One of them is your temperature. As far as you're working on that well, the first day that well was podded, they were able to capture temperature and pressure. True or false? The first day there was entry into the well. So what is the temperature? What is the pressure? And then as you're producing, you've been producing oil, you've been producing a little gas. Either the gas is coming from your gas that is evolving from the oil, or you have gas, you'll be able to measure your gas oil ratio in the field. Hello? They even have in situ equipment that can give you gas oil ratio now in most fields. So once you capture it, put it there, it will give you the other PVT parameters you're looking for. Clear? So I will leave this guy default. Let's believe they are just, it's showing me from the little you did, 56.58 is what kind of oil? GOR of 560 something. It's black oil now. You can see that it's not high. If it's high, maybe let's say up to like 5,000 to 10,000, you know, you're looking at volatile oil. So it's okay. Let's accept this one. We don't have information. So once we accept it and say, okay, it will create PVT parameters for us. Then the next thing is asking is that you're looking at a situation where you have 3 phases. Now we're looking at 1 phase. You can just leave this one default. You can leave it. You can say that it's 100% dry oil for now. Okay. But if you feel it's not so and you have SO and you have SW, you can write them. Okay? So that's all. Say okay. When you say okay, what happened? It has populated formation volume factor for you using those correlations I showed you. It has populated viscosity and it has given you your total compressibility. So we're done. We have created PVT and we now do create. So the moment you do create, the next thing that you need to do there is load. Where do we load our gauges, people of Nigeria? Or have you changed country? Where do we click to start loading those 2 gauges, Entraco? Good. I see you're learning. Go to KAQC. I've told you the approach I'm using is not the textbook approach. It's the approach that any day, anytime you're giving your gauge data, you can load and you can do what? Interpret. I don't believe in all those your slide. Okay, let's go. So you load. Is there anybody that doesn't know how to load? Go and navigate your this thing in your classwork. 6RS, Entraco, 6SS. Same thing like we did. Next. When you get to next, what do we do next? Everybody. Field. So once you put it in field, it has mapped out for you. This one, you're not following everything. It has mapped A to K. I started with lower gauge, but you can as well load upper or start with lower gauge. Are we okay? Okay, my time, my time. Okay, we're here. We know what to do now. A is showing us date. B is showing us time of the day. There is something here I want us to talk about. This guy is called delta time. Elapsed time since the start of the test. Do you understand what I mean by elapsed time? Hello? I will explain it better when we're doing the full analysis. Elapsed time, if I say you came to class around 8:30 today, by this time, what's the time? 11. How much time has elapsed since you came into lesson? It's just a difference. So it's like difference time. Delta T. Do you understand? This is the time that's elapsed since I came to lesson. So that is what the reference now. So in this guy, the reference is going to be the very first time. Every other time will be minus from it. Are you getting it? So you will see where we use it. So we didn't see it in the other gauge. That's what I'm showing you. Abi? So the next thing we have here is what? Your pressure, temperature. Please leave every other thing. If you don't define it, it will not pick it. So let's go on. You know what to do. Your date. Look at your own date. Please, this date is unique. What are we seeing in our data? 2017, 05, 18. So what is this date format? It no matter where you start, but we started with the lower gauge. We started with the lower gauge. So now I want to show us, can somebody tell me, looking at the screen, which one is the time format we should adopt? How can we adopt second one? Look at that thing again. 2017. It started from the year, is the last one. All the people that said the last one have my thumbs up. So that is it. You pick the last one. You see? Then the next thing is supposed to be time. What time are we picking? TOD. Good. So I don't want to define this delta time for what I'm doing now. Are you getting it? I don't want to define it. I'll just jump it. If you don't want to jump, you can click on define, like we did for that date. Then we'll go to what we know. The next guy there is pressure, right? Followed by who? Temperature. That's all. I'm not defining power up, and it doesn't have any data. So the next thing I do is to do what? To load. So apply to all if there is a time issue. So this is a typical test. If you understand this test and the evaluation we're going to do, you can interpret any other test anywhere, any day. Okay? So look at it. Bring in the other one too before I start explaining. We have done lower gauge, so we'll bring the upper one. The upper one should load without, you can see the upper one is already all green, Abi? So you don't need to arrange anything, it's already arranged in the format we gave it. So you load it. So to be sure, we have two gauges, which you can see. You can just use the legend to check. You can see Entraco 6SS has come in as a lower gauge. And in bracket, there is something you can see in bracket that was not there when you loaded. Ref. It's showing you that the lower gauge is the reference gauge. Because there is something we're going to do that is called QA/QC now. I'll just show you how to do the QA/QC, but we're not going to stay on it. I'll show you how it's done. Tea break time. We said we're giving it up now. You are not here. Please give it up, because anyway, very helpful during our interpretation. These are view icons. Like you see this one. When you click on your one, what is it called? Zoom what? It said zoom, mouse zoom on vertical axis. What's vertical? Up to down, right? If I want to stretch my object from up to down so that I see more, I use that. Then you have another one that is called horizontal what? So, okay, if I want to zoom horizontal now, okay, am I missing it too? It's like this, like this. The other one is like this. So we will need them, especially for this static gradient. I remember that okay, I wasn't in class, but I know that when you were taught and you were told that there are different types of tests. But if you want to do a full BHP test, what we call full BHP test, because what we're going to go into now is a full BHP test interpretation. I wrote something on the board. There is different types. Either you're doing a drawdown or a build-up test. Abi, if you're doing a build-up test, we usually use it as an opportunity to do some auxiliary tests. Those auxiliary tests, if it's a build-up, what will you do first? Because before there is a build-up, the well must have been flown for a while, and then the well will be shutting. Abi? Yes. So while you're flowing, what auxiliary test can you do? Flowing gradient. Then when you want to carry out your build up, after you finish building up, when you're about pulling out of hole, you can use the opportunity to do a static gradient because the well is shorting. So but if the reverse was the case and you were doing a drawdown test, what will happen before drawdown? The well must have been shut into stabilization before you will now open the well to flow for drawdown test. So you use that time when the well was shut in to do what? Static rest. So the reverse will be the case. And then draw down, and then after drawdown, what will happen? Build up. After, what did I say? Now do the flowing. Forgive me. I'm just changing the whole thing. So get note of that. So these two we just explained are full BHP test. So sometimes some people go to the field just to acquire only static. It's not a full BHP test. Some go there just to acquire flowing grade. And I know you were taught why they do that. Good. So some can just go and say it's only build up. They don't flow. They just build up the well and pick pressures. But when you see it like this, 3 in 1, it is a full BHP test. All 3 tests, now we have 3 tests in this. If you look at this, your data now, is everybody here? Please, if this guy is movable, you can move him down. If you stretch him down, the temperature is going to be louder. If you take him up, you're going to have pressure. So please do your own in a way that your pressure is showing more, because that's our interest. And make sure your pressure is active. Then when you do this, who is there? Lily? Me?
Normal, sorry, in events where there is maybe enhanced recovery method in my class, there is shorting where people go try.
Are we enhancing well before we shut it? Any well can be shut in anytime as long as the well is completed. You understand? Has nothing to do with
I'm
whether
aware that we produce the exam.
you can shut in any well or anytime. Different reasons. If there is a problem with the well, will you not shut it in? You will now. Let's say there's a leak now. That well is not safe again to produce at that moment. You can shut it for any reason. It's not only for VHP tests. It's not because it's producing well enough. Most times when you shut in for VHP, because you want to acquire new information, you understand, about your well. So please look at this test. If you look at this test, the only way you can see what I want to tell you now is that I want to explain a little bit. When the guy got to the field, remember when he said he powered up his gauge? Do you remember that story? When he powered up his gauge, when you power on a gauge that is supposed to be picking pressure, even you blow breeze or you talk, it will be picking the pressure coming from the air from your mouth, true or false? So you see, it was picking the pressures in the environment. But that's not his objective. His objective is to get to the wellhead, what we call the THS. Some people call it the tubing head housing. Some people call it the casing head housing. They're all. Then before it, there is a lubricator. Are you getting it? He can send his gauge to that lubricator. And the lubricator, they set it up here in the office before they even go to the field to be sure that all their BHA, what we call BHA is the borehole assembly, abi? You were taught in your drilling that everything is okay that they need. That everything is okay that they need. So he will power it up. The moment he powers it, you can see that it's reading. Is it reading? It's reading same pressure readings. Just check. It's increasing, right, as it's going down the hole until he gets to a point, maybe the limit. Oh, I'm pointing with my hand on my screen. Forgive me. So you can see that he has powered up his gauge. He's running in, and as he's running in, he's getting reading. Abi, from 0, you can see readings. It's reading. The only way you can understand what here and go to your entraco, any of them, lower or upper. Open, let's look at it. Because I might not come back to explain this. So look at this very first line where you picked your reading. What do you see? After the time, decimal, the lap time and all that, you saw your pressure. A typical atmospheric pressure is what? But what do we have here? It's showing that it's an enclosure in the environment where it has been put into something. Are you getting me? That's why it's experiencing that pressure that is a little bit above your atmospheric. Are you getting it? So we always used to say in chemical engineering we have this word we say at STP. What's the STP now? Standard temperature and pressure. So what's your standard temperature and pressure we use around the Niger Delta? 14 and what? 60 degree Fahrenheit. So now, but look at the atmospheric temperature, because this is at the point he powered it up. He put the batteries in the gauges. Look at what he's reading. What do you see? No, no, no. Okay, yeah, okay, 15 point. And then this one is in what? 80. So showing you that it's a closure, not an open space at that moment. Do you get it?
Yes, ma'am.
Good. So this becomes like your, will I call it, if you're to maybe do anything and say this was his own atmospheric pressure. So we use this also for QC. I need to see that here. And also go when he pulls out of hole. Please scroll this to the end. When he pulls out of the hole, is at the atmosphere, is it not?
Yes.
I should be seeing something close to 14.7 and 60 degree Fahrenheit. Are you seeing it? So it's close. Abi, this is to tell me that the gauge is working.
But
When,
the temperature is high.
you say it doesn't matter. They are in a closure now. That's what I'm saying. So
What could be responsible that the pressure is getting okay while the temperature is still very high?
is this okay? This is 14.3. I don't know.
But it's close, but the temperature
I don't know what happened. These tests must have taken 2 days, 3 days. Anything could have happened in the environment where they have this well. So, but it's okay. It's within range. So that's all I wanted to show us there. And then what else? Okay, we've talked about this. We've copied out this. Let's go back to our plot. We'll see. Go back to that thing. So what do you see here? When the guy was flowing the well, he was taking stops. I will use this my horizontal axis zoom to check. I'll just click on it and drag a bit. He was taking stops. Did you see something like a staircase? He was running in until he got to a particular depth. He stopped at that predetermined depth. There is undo. Anytime you want to undo, please. There is this icon that looks like a house. There are 2 houses there. One house has arrow, like SARS bullets. Don't click that one, it will fire you. Click on the one without an arrow on it. Have you seen it? This one does not have any arrow on it. So this has brought it back to default. Did you try it out in your own? It has brought everything back to default. Okay? So, are we all there? So I was just trying to explain the test that was carried out. They had that flowing stop. Is that okay? After the flowing stop, he got to the target depth. This is the target depth. This is the target depth. At the target depth, what happened? He stayed there for a while and flowed the wells. If we go back to that storyline, hello, let me use it from the story. Let me read from the storyline. Did you see? He opened the well to the lubricator. Please read the next one. Read the. He observed how many minutes at the lubricator. Then what did he do next? Just arrow IH means run in hole to a depth of what? 10 feet. So this your depth of 10 feet corresponds to this point here. This first step. Let me just open it small. It corresponds to this point. Are you seeing it? He got to this 10 feet and he stayed for how long? 5 minutes. Okay, let's go back to the storyline. And then read it again. What did he say? The next thing, what happened? Observe what? 10 minutes at that. Good. When he left there, he ran in hole again to where? 1,000 feet and 10 feet, are they the same? One is deeper than the other, right? So he's going down. He has a target. That's where I'm coming to. He stops at different depths. He collects pressure. He goes deeper, takes another depth. So, but that debt is always given to him by the company people. They know the depths of interest where they want him to stop. They want to observe pressures and those debts. You see what it will give us at the end of the day. So just be patient. So let's read on. He went to what debt? 10,000. Then after he observed how many minutes did he stay there? He ran again to what debt? He stayed how many minutes at that 4,000? He ran again to what debt? And he stayed how many minutes? He ran again to what debt? And he stayed till what? He ran again to what? And he said what? He ran again to what? Where? Please watch what is happening. The moment he got closer to the formation depth, his depth started reducing from 8,000, he went to 9,500. It was not like up to 2,000 feet apart again. 9,500, he went to what? 10,002. You can see that they are closer now. Abi? And then where I want us to get to is where he ran. Read this last one, the one in color. The one in color, what did he do? Towards maximum survey depth. So that target depth is what he was aiming at. That target depth is close to where his formation is, close to his perforation. Are you getting it? Close to where he can experience the pressures that are coming from where the formation. So that depth is where he stopped. And when he stopped at that depth, he did something. What did he do? He observed a longer time. How many minutes did he observe at the target depth? 30 minutes, not 10 minutes, because he has reached close to the formation where he wants to stop. And then when he got there, he did two things. He did two more things. I want us to look at the story so that when we go back to the gauge now, we'll see what happened. He now did something. What did he do? He shot in the well. So we have shot in one. I can call it shot in one because I want you to write it out. And when he shot in, he did a change of what? From what to what? Now, when you increase your choke, what effect does it have on your rate? Increased choke will give you increased rate. And increased rate will give you what kind of pressure? It will draw down your pressure. When you're producing more, your pressure will be coming down. Please, I want you to marry this correlation because that's what you will use in the interpretation. So where we have a higher rate, we experience a higher drawdown. And when we have a higher choke, we'll see a higher rate than the previous. Clear? So the first choke change he had was what? 20 to what? To 24. Then he changed again. He opened the well to flow on this choke. After a while, he did again. He shot in because he was changing choke. He changed from what choke to what choke? 24 to what? 28. So I should experience a higher rate. And then he moved from another choke. He went from what? Okay, at that choke, he now stayed there at 28. So I should be experiencing how many rates from what I see here? Let me go back to home. This is the first flow. Hello? So can we say that this flow and this flow is not the same because the choke sizes are not the same? This was at choke size 20, Abi. He changed it to choke size 24. More rate, and the rate showed in the pressure by drawing down the pressure more. Is that clear? Good. He changed from 24 choke to what? 28. What did the well experience again? The drawdown was higher for the pressure. So I have rate 1, drawdown 1, drawdown 2, and drawdown 3. Is that clear? And then for him to be able to make these changes in choke, he was shorting in. So for those shorting, when you short in, what happened? The pressure will build up, right? So I have build up 1, Abi. He changed choke again. I have build up 2. Then I have my final build up 3. So we're going to capture all this when we're doing the interpretation next. But for now, I've just explained what kind of test that happened. It was a build-up test. He had some flow before the final build-up. and he had to change some chokes. That made the rates to increase, and the rate affected the drawdown. Is it okay?
Yes, ma'am.
Good. So let's move. It's a build-up test. What we have here? Before in your theoretical class, Prince told you, and I know I wasn't here, but I know he told you that before there is a build-up, there must be what? Flow. There must be flow before you shut in. So that's what we're doing. We're flowing the well before we finally shut it in. And the essence is that when you're flowing the well, you want the formation fluid to start flowing.
But no, that comes that the line is not uniform.
Somebody else, I will not explain. Somebody else explain this one.
Okay.
We just explained that change of choke means change of rate. Abi? Good. And as the rate changes, the pressure drawdown will be higher. So that means it's pulling down on your pressure more. Clear? Okay.
Anytime we are interpreting that, and we see this one.
Like me, now if I'm interpreting this, I will know that the rate here is higher than the rate here. Is higher than the rate here. I'm using the pressure to interpret the rate now.
But this length can
This length has to do with the duration of flow, how long it was
when
flowed.
the duration is long, very long.
Doesn't matter.
It can have a very long duration, like
If you flow for the whole day, 24 hours, doesn't make it. As long as it's on that choke size, it will have almost a uniform rate. Is that okay?
That doesn't mean that is the final. Yeah, that is the final should be changed. For example,
You don't just change choke anyhow in the field. If the need arises, or maybe you're doing a test like MER test, you can be doing all those changes. But now they did this change because maybe they wanted to capture both the MER and then do the. You see, otherwise, they would have flowed only once like this and then build up. It's still okay. But there must be a flow before
you short it.
before you shut it. It could be a single flow, it could be a multi-rate flow. In this our case now, it's a multi-rate flow. Is that clear? You say no, there's another kind of test you were taught now. We call it maximum efficient rate. It's like a kind of test that the what do you call them? The regulatory bodies want to use to assign rates to your wells. Oh, don't worry. I'll answer the question. Okay, so let me not. You're taking my time. Oh. Okay, so let's go straight. Now we're going to interpret the flowing gradient. Is there anybody that didn't understand this test? So now let's interpret the flowing gradient. I'm going to see the one I use, this horizontal zoom, this thing. So use it to change to a cross like this. Click it very close to where you have your this thing. And drag it to your right. Are you seeing how I drag my own? I've not released my hand. Or do the same thing. Then when you release your hand, it's just to enable you to see this very well, but you can't see it very well the way you want. To see it well, go and take the vertical zoom, mouse zoom. I picked that vertical one. I place on this top. I drag it to this end. Is that okay? So I can see the stops better. I'm back to home. I use the horizontal to 10 feet. He waited for how many minutes? 10 minutes, Abi? So that wait is what gave you this flat. As he went deeper into the well, he got to another point, 1,000, Abi? He rested for 10 minutes. He left the gauge there to capture the pressure there for 10 minutes. He moved in. You know, the deeper you go in your formation, the higher the pressure. See what is happening here? He got to what's the next one? 4,000, Abi? He rested for another what? 10 minutes. That's why you're seeing all these cases, the rest. So that's where we're going to capture our pressure from. So to do that, in Sapphire, we use this icon called gradient to do it. Click on gradient. The flowing stop. Click on gradient. I only click on gradient. I've not done any other thing. Once you find yourself there, what do you do next? We want to capture the pressure. This is, okay, let me explain to you. Your flowing gradient, according to your material, please, come and help me bring up the material. Let's go back to flowing gradient, please. Flowing gradient is used to capture pressure with depth. At every depth, predetermined depth, you capture the pressure at that depth. Did it make sense? At every depth, you capture the pressure. At every depth, those depths must have been predetermined for you to stop by the owners of the well. So now, you cannot see the pressure. Can you see the pressure? We want to capture the pressure. And I said to capture it in Sapphire, we use a module called gradient. Under that your load, you see the module, their gradient. Click on it. Let me go back to click. I cancel what I've clicked. I go to gradient. This is the gradient. You have load where you loaded. You have difference. We'll come back to this difference later, but I don't want to scatter our work. Click on gradient. When you've clicked on gradient, it will give you this interface. Now it's asking you pick points for your gradient. Now, if I say somebody came to my house and stayed 10 minutes and he was sitting down to rest, if I want to measure when he has actually stabilized, like midway to when he came in, like 5 minutes after. But at that 1 minute he came, he has not stabilized enough now. So the gauge is sitting at a particular depth. The gauge sits there for 10 minutes. So I will just be picking halfway into the timing it has sat in that place. Are you getting me? So now, what I will do, you press OK. It's asking you, pick point for the grade, and then when you're done, press return or escape to cancel. So I pick here, I say OK. Once you click on OK, it changes to a plus sign. So the first depth I'm going to pick is this 10. See where I am? At the middle point, I pick. If you pick, anyone you pick, any depth you have picked the pressure, it will show. And where you picked it. I go to the next depth. What's the next depth from what we have? Lillian, write out all the depths for me. The depth is not written, but we have idea because the gauge man gave us a report, which we all read like chorus here. Did we not read it? We all read it. See his depth here. This is where we're reading from. He told you that when he powered up the gauge, he opened it to the lubricator and then ran in hole to like 10 feet. Is it not? So our first depth is 10 feet. The next depth, after resting for 10 minutes at 10 feet, he ran in hole to 1,000 feet. So our second depth is 1,000. That's how we know. Not that it's written there. The next depth he ran in hole was 4,000. The next depth he ran in hole was 6,000. The next depth 8,000, 9,005, 10,200, and the last depth, which is his target depth, was 10,300. So that's how we know. So count for us how many stops. That's how we know all the stops. So I'm picking the next one. At the middle, pick all of them at the middle. This is for stabilization. God bless you. Don't pick at the beginning, no. Lillian, how many stops altogether? How many stops? 9. So, yes, the last one where he rested. 1, 2, 3, 4, 5, 6, 7.
So what do you have in your design?
We should have one. We have one here.
Yes, how many? When they have added more.
Oh, I want to click somewhere else. Oh, no, what happened? Okay, that is it. The stop depth now, where he stopped and flowed. You have to pick that. I just want to see here. Is it now? That's the stop depth. Count. How many did you count?
I'm having 9. I don't know that worked together.
Are you sure you're in the flowing?
10, 1,000. See that Excel.
Let me just drop it here and see. Where did you get that? It's only one. see now, this and this.
How many are these?
So I should be about.
1,000.
Let me see what depth. So how you can check it? You can. I can't zoom here now. Just enter. After we'll talk about it. Have you entered? So see, I'm coming to an important thing now to us. This software does not capture the depth. It's you that will enter the depth that you stop. It is reading pressure and time. Don't forget. The software, or will I say your gauge, reads pressure and time. So now you're the one to key in the depth. But when you're keying in the depth that the wireline man captures in the field, Lily, I need your help. The depth the wireman captures in the field is called measured depth or along hole depth. In fact, use the word along hole depth so that you understand. You know, in well architecture, you can have well that is J in shape. True or false? It starts like this. You can have X. Have you seen it? Especially multilateral wells, especially all those deviated wells. So if somebody is giving you a long hole depth, it's giving you a depth where he's going to pass through all those, is this splinter, whatever you could call it, just pass through it the way the shape of the well is. But in doing your static and flowing gradient, we use what we call true vertical depth or true vertical depth subsea, TVD-SS. Never use a long hole depth gotten from the wireline man for this. You'll be telling them wrong, giving them wrong information. So now, do you know how we convert your a long hole depth or measured depth to TVD and then TVD-SS? Can somebody give me an idea? From your petrol you've done, there's an information you need. What's that information that can help you convert your a long hole depth or measured depth to your TVD depth and then reference depth? It cannot be reference. I just say there is an information that is needed. That means it's a data itself or it's a file that you need to do that conversion. Agala, do you have idea? You need, when you were doing petrol, for goodness sake, one of the things you loaded was your deviation data. Is it not? It shows you X, Y. It will also give you your azimuth, give you your inclination, give you your degree of deviation. Is it not? That's the only thing that even the well designers, or we like all the well part designers, cannot design a well and will not output the parts, the deviation data for you. They will give it to you. So if a company gives you well tests or data to interpret, please, whether the person says it's deviated or not deviated, ask for your deviation data. Clear? Even if it comes in ASCII, convert it to Excel so that it will help you use what we call interpolation to get the in-between depth. Because the depth the company man must have prescribed, like this 1,000, 4,000, might not be in your deviation data. But you'll be able to get in between using interpolation. Who doesn't know what interpolation is? Interpolation is, I have A is 500 and B, they are the same thing. B is equal to X. So what is X? That kind of interpolation, which you can do quickly with your Excel. So just write it down that we use deviation data. And in your deviation data, what it does, it will give you, if you open the one you have in your system now, you will see MD, that's their long hole depth. The next depth you see was TVD. So you will see most of your depth, their corresponding TVD. So where you don't get it, do the interpolation, the in-between by yourself. I don't know if you understand. So that in-between has to be a depth shallower and a depth deeper than the one you're looking for. Did that make sense? Okay, so now we're going to assume that this is our TVD, but it's not. Oh, TVD depths are always lesser than your measured depth. You know why? Mindful. You cannot you cannot come and write 10 here, or 10 cannot give you 2,795, whatever you call it, PSI. So you start from here. This is 10. The next depth I have is what? 1,000. The next depth, call them for me. Enter your TVDO, not your MDO. 6,000. Next one. You say? Please be entering your own since you know it. 9,500, Abi. What's this one? 10,2. Why did they yeah, it says it's close to the formation. So you want to capture detail. Final information now. That's your interest. That's your area of interest. Okay? So are you done? Once you're done entering, you have it. See, this same thing you have here, you can copy it and go and plot it in Excel. How do I copy? I just highlight everything. Control C. I take it to an Excel file. If you're interested in plotting it on Excel, because some people like the virtual, we like call it. They like the plots. They can manipulate the plots in Excel, but here you cannot manipulate plots. You understand? So I've copied my own art. Later I can go and plot it. So for now, we are done. So if you look up on this tab, you see grid. After grid, what did you see? Plot. So click on plot. Yes, I am here. See all the pressure it observed around 10 feet. So he had 1,599. You that means you picked very close to this thing. Okay, it might not be, but you know that this pressure is capturing is per minute per second. Anything can happen and to change. See all the pressure, but the average of all this thing, you can use it if you want to use it directly here. But if you see, if it's in Excel, I can just do average of all this one. Only this, and I'll get what the average pressure at that depth was. But now we're not looking at it that way. I picked around the middle. That's why it's giving me that value. Are you seeing? You not now. You know how gauge is. If maybe you were observing the gauge and somebody shake this in a little, the reading will jump. I don't know if you get it. So anything. But now we're just imagining that at that mid time, 5 minutes after it has now, if around that your graph sheet, how do you do it? You know, you put from here to here, then it will calculate for you, or you calculate it yourself. Change in X over change in Y, abi, or change. So that is what we're doing here. So I'll pick a regression line. So I put this. You can pick any of these arrows here. You have yellow, you have blue, and you have red. Is that okay? So I come here now. Are you here? So I'm able to fit in one line. Pick any color, red, blue, anyone. Have you done the same thing I did? Okay, if you're here with me, you can see that the slope has been calculated. The slope is in PSI per foot. So when somebody tells you that the gradient of this well is 0 point something something something, are you getting it? If it's so 3 different fluid, it will also give you 3 different fluid gradient. Are you getting it? Slopes. But looking at this one line was able to fit in for it. So that means when this well was flowing, only one fluid was flowing in the well.
Is it possible? Because for everything, water can use it.
I say it's possible. A well that does not have water will not give you water when it's flowing. Yes, now it depends on how you're flowing your well. You can have only single phase flow. We have saying, and that is what everybody fights to get. single phase flow. So what we have here is a single phase flow, and it's giving us a gradient of 0.1165. That is very light oil during flow. So I said one regressional line was able to fit all the data points we have. So meaning that we had one fluid during flow, during the flowing stop. As the well was flowing, only one particular fluid was flowing, and that's the fluid gradient. But maybe it could be mixed with gas, but you can see that it's just a light fluid because of the fluid gradient. I wish I can get out the fluid gradient for oil, for gas, and for water. But if it was gas, it would be giving you something like 0.01 something. Are you getting me? You know that it was a gas, a gas well, or a gas that was producing at that time, that was being produced. But this one, this gradient is giving me gradient that shows light oil. So what is the usefulness of this gradient? The usefulness is that I can calculate pressure at any point in this well. Because if I know the depth, I will multiply the depth by this fluid gradient and I will get the pressure. That's the significance. But what they want to use it to do is to know the type of fluid I was flowing. So if you had heavy fluids like water and others, they will be able to see it and at what depth that fluid was flowing. Okay? So, no, the intercept usually works when you have is more pronounced when you have 2 or 3 fluids here. Like maybe when I finish, I'll just show us example. Nina, do you have any? Okay, later. Show us example of where you have more than one fluid. So the intercept is like the interface between one phase and the other phase. Water and oil and gas. Are you getting it? It shows you at what depth. That intercept is a depth. This is so, but it's giving you that the interface for this very light fluid ends around this 1,000 something psi. So just yes, so
What you explained, if it is, for example, assuming gas is water according to the three lines.
yeah, you see 3 slopes. The slopes will be different. Maybe after all this one, we'll show you what it is. So this is our plot. You can as well copy it. You can copy what you have here in case you're reporting, but you can say okay to accept it so that you can see it.
How do
So
you copy it? Because we are like this.
you can snip it now. If you don't snip it, you can later I'll show you how to go to report. This output can go to this output now. You see, you can just say you want to preview the report. When you click on that, you can click on your this and all the things you have that you want to see. You can push all of them and then say preview. When you say preview, it's going to show you all the things that have been captured. But this one now we are not done, so I'm not seeing. No, I was trying to show him something. Don't be lost. It doesn't concern you. So can you see your? So you can, if you want it plain like this, you can pick it from the report. If you want it plain. So this is what it has plotted for you. This is the information. But it's like jumping the class. Please don't go there. So we're still in gradient. We're done with this. You can go back to your home. This home, return it to home. We're done with interpretation of the flowing gradient. And we have this thing. We have our gradient, our flowing gradient. So the flowing gradient was what? 0. What? 11 what? That house up. This house without an arrow. Yeah. Yes. If you go back to gradient, it will ask you, use the link between this guy and this guy. Just say yes so that you can see. This is all you have. You can see plot it. It's still there. Do you understand? It's there. As soon as you have click OK, it's there. So if I click on this line now to show me the slope we calculated. So it's there. As long as you save it, it's there anytime. So now we're done with that.